Hello viewers, in today's class we are going to discuss one important problem related to integral inequalities, right? And in this problem we have the integral 0 to 1 x square plus 2 divided by x square plus 1 dx is less than or equal to 3 pi by 4, right? So what we have to do, we have to estimate the value of this integral, and we have to show that the value of this integral is less than or equal to 3 pi by 4, right? So let us start. So now let us first take this integral as I, right? So we have 0 to 1 x square plus 2 divided by x square plus 1 dx. And see here, the lower limit is 0, the upper limit is 1, right? So our x, it belongs to the interval 0 to 1. And to get this inequality, we have to start with this inequality, that is x is less than or equal to 1 and greater than or equal to 0, right? Because x belongs to the interval 0 comma 1, right? So x is greater than or equal to 0, less than or equal to 1. So let us take this part of this inequality, right? So to start with, we can take x less than or equal to 1, right? Okay, now here we have x square plus 2 in the numerator, right? So we'll first try to get this term x square plus 2. So what we will do, we'll take the square of both sides. So we'll get x square, and here we have 1 square, which is equal to 1, right? So here the direction of the inequality remains the same, as x is greater than 0, right? So there is no harm in squaring both sides. So x square is less than or equal to 1. Now let us add 2 to both sides. So what we will get, x square plus 2, and here we have 1 plus 2, right? So x square plus 2 is less than or equal to 3. Now see, we have x square plus 1 in the denominator of x square plus 2. So what we will do, we'll divide x square, both these numbers, by x square plus 1. So we'll get x square plus 2 divided by x square plus 1 less than or equal to 3 over x square plus 1, right? So here one thing is very important, that is x square plus 1 is never equal to 0, right? Because x is greater than or equal to 0, so x square plus 1 is never equal to 0. So there is no issue in dividing this inequality both sides by x square plus 1, right? Now see, here we have one function. This is a rational function, so we can denote it by f of x, right? And here also we have a rational function. Let us denote it by g of x, right? So we have two functions, f of x and g of x, which holds this inequality in the interval 0 to 1. Now from the integral inequalities, we know an important result, that is, if f of x is less than or equal to g of x in the interval a to b, then the integral a to b f of x dx is less than or equal to a to b g of x dx, right? So we have already discussed this property in our earlier videos. So fx is less than or equal to gx. So let us integrate both sides from 0 to 1, right? So 0 is a, 1 is b, right? So 0 to 1 f of x dx is also less than or equal to 0 to 1 g of x dx. So we can now write 0 to 1 f of x is x square plus 2 over x square plus 1 dx, and then we have 0 to 1, g of x is 3 over x square plus 1 dx, right? Now this integral is I. So we have I less than or equal to 0 to 1. We can take this 3 outside the integral, then we have dx over x square plus 1. So now we have to find the value of this integral 0 to 1 dx over x square plus 1. And this is a very elementary integral in integral calculus. The integral of 1 over x square plus 1 is tan inverse x, right? And limits are from 0 to 1. So we have tan inverse 1 minus tan inverse 0. So this is pi by 4, and this is 0. So here we have pi by 4, right? So now this inequality becomes I less than or equal to 3 times pi by 4. The value of this integral is pi by 4. So I is less than or equal to 3 pi by 4. And this is our desired result. So this is how by making use of this property we can solve these kind of problems.